Reinforcing bar is the most used construction metal. Although they are embedded inside concrete, they act as the main tensile support of the structure. Welcome to Construction Materials and Testing. Although concrete is a strong structure, imagine what can happen in a concrete structure when it would be under the application of different loads. It is true that concrete is strong under compression, but it is weak in tension. Thus, it needs to be reinforced by rebars which can complement its weakness. That is, steel is strong in tension but also weak in compression. There are different names for reinforcing steel bars, which are rail bar, rebar, Y-bar, N-bar, and also deformed bar. The last name is also the general name of steel bars, which we are going to discuss further in the succeeding slides. Reinforcing steel bars come into two different forms. One is the plain bar, which from its name would mean the surface will be smoothly circular. This type of bar can also be used as a reinforcing bar in a concrete structure, although it is less preferred. With its more monolithic surface, it is used in grille works. Deformed bars contain ridges on each surface, and these marks act as extra reinforcement as they minimize slippages when installed into concrete, thus provide an increase in the bond for the two materials. Different grades of rebars are available to cater on the various designs and structures. The grades are categorized according to their tensile strength, such as grade 33. Grade 33 rebar would mean that one can expect 33 ksi or 33,000 psi for its tensile strength, that is in English units, or 230 megapascal in SI. This grade is called structural grade, and this is the most commercially available in smaller merchants. A low-grade steel, such as grade 33, is sufficient for structures considered as low-rise or those which would have 4 floors and lower. Upon checking for supplies on this grade, one can check the two ends of the bar. The standard marks are again divided into the regular bar and weldable bar, where both ends will be painted white by the manufacturer to show grade 33. If one ordered weldable bars, he would expect a white and red paint on the two opposite ends. The next grade is 40, which would mean 40 ksi or 40,000 psi tensile strength, which can then be converted as 275 megapascal in SI. This is a little bit higher in strength, and it is called intermediate grade, which would be used more often for mid-rise buildings or those which are from 5 to 12 floors high. One can observe two yellow marks on both ends for non-weldable bars and one yellow and the other red for weldable bars. The higher grade steel is grade 60, which would have a tensile strength of 60 ksi or 60,000 psi, which is then same as 415 megapascal. This grade is used for high-rise buildings including skyscrapers, which are 13 floors and more. Manufacturers would have designated recognition of this type of steel bars by painting green on both ends for regular bars or green on one end and red on the other for weldable bars. There is even grade 75 steel rebar used for especially high structures with designation of blue and green on opposite ends. Sizes of rebars are given using their diameters. From the chart, nominal properties of steel rebars are represented as they are useful in both design and construction. Although the most used minimum size of rebar is 10 mm, there is still a smaller size of 8 mm or D8, most often used for grille works. The largest diameter which can be used in design is 36 mm. The commercial lengths of rebars would start from 5 meters, although this length is not much available. 6 meters is the most commercially available length with 7.5 meters. Longer lengths can still be bought through orders, that is 9 meters, 10.5, 12 meters, and 13.5 meters. Note that the lengths would have an interval of 1.5 meters. Weight of the bars is also of importance, as one should know how heavy the materials are if they are ordered to know the capacity of each truck. In most cases, orders would have to be limited to 2 tons, the capacity of a flatbed truck. Another important consideration is transport. The features of the road would need to be taken into consideration in order to avoid any inconveniences when transporting long lengths, as it may be dangerous for the driver to maneuver the truck in such case. Depending on the design, rebars can be used as reinforcement in concrete structures. Most often, the smaller diameters of D12 and D10 are used for lateral ties in columns, stirrups in beams, slab reinforcement, wall laying, and others. The bigger diameters are for main reinforcement from the foundations to the beams. In design, as one would have to meet the requirements imposed by the load, economics would be still considered, thus design would start from the smallest possible diameter, but then, if the rebar isn't enough, say we already exhausted D36, yet the design load still requires more. Multi-layering is a possibility, especially for beams, or the other would be bundling of bars. Such methods would be further discussed in design subjects.